something like that. What I was saying though, actually probably not like eyes and such, because those are organs, you know, those are same species and stuff, maybe different species though. If you want to get an idea of some kind of halfway decent idea of what's going on in different species, maybe or maybe not, science would maybe look at something like this in the future. But like you could say, like maybe you wanted to like see like a bat, see what a bat sees. Bat has that echolocation, kind of a sonar thing going on. They go flying around making noises. Those noises bounce off of objects, and then they get those noises after they bounce off objects back into their ears, and they're able to make a view of reality from that they can even like catch mosquitoes and moths and such. You know, it's pretty remarkable when you think about it. They're flying around, you know, in the air. I mean, can you even imagine catching a beetle or a mosquito flying around in the air, you know, at your size and all that such, you know, with sight? Probably you can't. And they can do that with sound, let alone hearing. I mean, you know, I can hear the mosquito, there it is, I catch it. You know, I mean, they're making this view of reality, bouncing the sounds off of everything, and that's how they do that. It's kind of remarkable, I think. Now, what if human beings were, you know, able to get that same stimuli? You know, maybe you take some bat, and, you know, maybe in a lab, you don't kill the bat, even have to. You could just, you could, take some tissue from a bat, and you could cause the tissue to turn into those organs. And then you could, you know, hook some signals up in a person's brain, and then you could, you know, maybe, you know, could just put those little signal and put those little ears right here or something like that, and maybe put the little, you know, signal generating thing right here, and, you know, it could even be wireless or something like that, and then the little, you know, you could see if you could see what a bat sees, kind of. Of course, what the issue is there anything to do with our brain, like, you know, the actual genetics and the, you know, construction of our brain that that would, I guess, not give us the same perception as in a bat? Probably, but we don't know for sure. We don't know the significance of it. These are all questions that we can't even really, we don't even know how to get to right now. Or we can. I mean, I can, you know, formulate this question, I guess, but I mean, these are things I don't even know if people are even thinking about this stuff. That's kind of interesting, and you can get some better understanding of what the heck, you know, things about perception. You can get some understanding about, you know, I guess all the science of mind. That's kind of those are potential experiments you could run to figure all that stuff out. So that's kind of some of the unknowns and the unknowables, potentially knowables, but potentially not. So we just have our own experience of reality, and that's pretty much it. We don't have a front row seat to everybody else's. So now I'm going to go on and talk a little bit about what does all this philosophy that I've kind of talked about lead us to the future. Well, near term, the pace of technological advance will increase, will quicken, and it will continue to do so. It's been doing so. You know, if we look at the last 100 years, 200 years, it's an exponential curve. It's going up, you know, up. More change in the last 10 years than in the last 50. More in those 50 years, in the previous 2,000 years. And, you know, it's an exponential curve. So, you know, you look at computers and such, you know, you look at, you know, the speed, Moore's law, the speed at which computers operate, or the number of hertz at which chips can run, it doubles like every 18 months. You know, if you go on that rate, I mean, we're basically, what I'm saying is, and this is what a lot of other people kind of say or have this concept, is that we're approaching a point where machines, computers and such, are going to have just as much computational capacity as human beings or brains. Not only that, but we're quickly approaching a point where human beings might even have computers with the capacity to think at a human level, or, you know, even beyond that. Now those are some points that are quickly approaching us. You know, some people say 30 years, some people say 50 years, some say 100, some say 1,000. I mean, if you look at the curves, it could be like that's where the people that say 30 years come get their reasoning from, is looking at those curves of the way things have been going lately. And I personally think that's not 30 is definitely not out of the picture. I mean, I'm more of a 50 guy, but 30 could be 30 years. You know, I don't know. That's just kind of like a personal thing. I think some things will probably happen that might, you know, be hiccups in the processes or things that we probably don't identify. But I think in general, the exponential is not, it's not going anywhere. So, but you never know. I mean, lots of things can happen between now and then. But yeah, I really think that there's not a lot that can really stop it. I mean, the infrastructures are in place, the institutions are in place. Yeah, sure, we could have some, you know, real big economic downturns. You know, we can run out of fossil fuels to some extent, but really nothing like that's going to happen. Is going to be enough to really, you know, more than upset by a couple of years the point at which humans will be surpassed by machines in intelligence. So there's some issues with that. So why in the heck are we making all this technology, right? Why do we make video cameras? Why do we make computers? Why do we make cars? Why do we do all this? We did this to save our own butts, you know, to protect our own genes and, or at least our